e of t be equal to some function that we know very well. How about t squared plus 1? And let's try to figure out, and v is standing for the velocity here, and I don't really care what the units are, but we're going to find the area. Let's estimate the area between v of t and the x-axis t-axis, that is, let's go from 1 to 8. And now I could ask you to do this in a variety of different ways, but let's say in our first example here, let's find it with 4 rectangles. And let's use a right-hand sum. So what's the dream here? I'm going to draw this just to have a sense as to what it is we're looking at. We'll have a t-axis, and it should look something like this. Now, it's not as beautiful as I am, but so be it. There's v of t is equal to t squared plus 1. And I want to go from 1 all the way to 8, and we're going to estimate that area. So if I want 4 rectangles, first, the rule is we have to figure out what the width of our rectangle is, and that'll be 8 minus 1 over 4, so 7/4. And I picked something ugly intentionally. This is going to be equal to 1.75. Fine? So, if I was going to do a right-hand sum, so I'm going to split this thing up into 4. So here's 2, and there's my 5 divisions for 4 rectangles. And I wanted a right-hand sum. And so I'm going to be using 8. I'm going to be using 6.25. That's 1.75 less. I'm going to be using not that one. I'm going to be using 6.25. I'm going to be using 4.5. And I'll use 2.75 as my 4 heights for my rectangles. And so I could write this as v of 2.75 plus v of 4.5 plus v of 6.25 plus v of 8. And I know what you're thinking right now. You're like, oh my goodness, Paul, you forgot to think about these little areas because the rectangle is going to be the base times the height. I say, don't worry about that. I'm just going to put that at the very end, 1.75. I could run this in my calculator, and I will, and I can get an estimate for this value. Well, friends, I've calculated. I got an area of about 236.031. And that's it. That's it. I mean, so we can certainly tell that this area is bigger because I have all of these pieces that are hanging off the edge, yes? So now let's do this again. And how about let's use 13 rectangles. And a left-hand sum. Now, I know what you're thinking. You're like, 13, oh my God, that's terrible. But, I mean, it's a process, right? And we should be able to think our way through the process. We're going to start at 1. We're going to finish at 8. We have our function v of t. And, of course, we have to start out with the width of our rectangle. And the width of our rectangle will be 8 minus 1 over 13, which is going to be 7/13. Yeah? Now, if I was going to start here for my first rectangle, that's fine. The height will be v of 1. And I could multiply that by 7/13, the width. We'll do that this time. And then the next height is going to be 7/13 further than 1. So I'm going to say v of 1 plus 7/13. Good? That I've gone 7/13 down the road, and there we are. And that number is going to be v of 20/13, but I don't even care about that. I'm just going to say v of 1 plus 7/13 is my next height times 7/13, which is my width. And then the next one will be 7/13 more than this, so I can say v of 1 plus 2 times 7/13. Until exhausted from my toils, where is the final rectangle going to be? Well, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes? We're going to have our 13th, no, our 12th rectangle. Our 12th rectangle. V of 1 plus 12 times 7/13. And the reason that we know we're not going all the way over, is that if I went 13, it would be 13 over 13, and that would murder itself, and I would have v of 8, and that's not the height that I need to use. I need to use the height right before it. Yeah. So, not a good picture, but that's fine. So what's going to happen here? I can factor out the 7/13. And we can be left with this little expression here. V of 1 plus v of 1 plus 7/13 plus v of 1 plus 2 times 7/13 plus v of 1 plus 3 times 7/13. Until exhausted from our toils, we wind up with v of 1 plus 12 times 7/13. Now, I'm going to cheat. And these are called Riemann sums. And what I can do is I can look up Riemann sums, and I can find Riemann sums calculators online, like I have here on Wolfram Alpha. And I'm going to ask it to figure out the left-hand sum between 1 and 8 of this function. And I'm going to come up with a number. So my area is approximately 160.71 from the Riemann sum calculator online. And what we can finally take away from this is, which of these do you think is closer to the actual area underneath the curve, the actual distance traveled? And it should be pretty clear that here I have all of this hanging stuff over, and here I've missed it. It's certainly an under approximation, but this under approximation is going to be closer to the actual value than the one that I got with 4 rectangles. So the more rectangles that we make, the less extra space I'm going to have on my curve. And so this should be more accurate than that was. Okay, in 5.2, we are going to discuss how to get the exact area underneath a curve and what that means.